Hello, everyone, and welcome to the podcast. I'm newtmechanist, and today we're continuing our game development project. Today it's about circles. Before we get going, let's check in with the kitties that we can see. I believe we have Sherbet up on the cat tree down there. We have Mason on the bed. You can see kind of his back at the top of the camera there. And then we have Ember being an absolute clingy nuisance right now. She is orbiting my head. Several of the cats have learned the ways of Sherbet, and that he discovered that he could traverse the headrest from one table to another. He then discovered that he could use my head as a backrest and lay down and get back scratches. And then Sky learned it, and now Ember has learned it. Masoom, one, welcome. And two, this is the cat cameras. I have 8 cameras set up to find my cats. So let's say for now we're going to go window cam. We tend to lose the cat on window cam. And we'll switch over to our view here. So yesterday we were trying to tune how orbital movement worked. So a core element of the game is being able to mix and match patterns of movement, and that they are supposed to play nice together. They're not playing nice together. When it comes to orbits and spirals. Orbits and spirals rely on forced directions. Forced positioning. And that's disruptive of the other ones. We don't want the force being applied proportional to how far it needs to go in order to get into the orbit position, because that will always counter other types of movement. But we don't want it so weak that we can't enforce an orbit. What this will ultimately mean is that fast-moving creatures can distort the movement. But we'll see. We'll see. Hello, Ice Drake. Welcome. Seriously, Ember. What? What's the matter, huh? She's extra needy right now, so she gets back scratches. And hello, Z. Welcome. Alright, so one of the thoughts here was, instead of... We're going to ignore growth rate and that kind of thing right now. We're going to just look at the general velocity of the projectile as it moves in a circle. So we need to remember which direction it was last moving, where it needs to be, and how we're adjusting that. Now, there's going to be some wrinkles to this that we need to work out. But I think we'll figure it out from there. So, what we're looking at is something that is moving around a target location, either where it initially appeared or around a creature. So let's see if... I don't know if we still have an example of this. Okay, we have broken examples of this. Let's slow down the spawner. For those not familiar with the channel, we are working on a game dev project right now. And one of the elements of that is to have weapons that are modular mid-game. So in this case, we have these little... One of our test cases here are these little mice that rotate around a random enemy. They fly out, they rotate around them. A lot of the behavior that we're seeing, though, is because the orbit strongly pulls the object to an exact position. It is like a clock hand that rotates around the target object and says, okay, the clock hand would be pointed here, drag the object to this exact point. That's not really what we want to have happening here. Or at least if it's happening that way, we want it to blend better with other forces, which means it can't drag that hard. Part of that means we need to reconsider how orbital motion works in that context. When it comes to things like homing on targets, the projectile is being told the object is there and it's in that direction from you, and then it will usually have movement that says just move in whatever direction you're being told to move it, that is where you're looking. So it will go in that direction, and that direction could be constantly changing if the target is moving around, or the target could have just been a fixed point in space and it just moves that way forever. Things like orbital motion, though, are where this gets interesting, because we are not applying the direction that we're looking varies over time. And I think that might be part of the issue here. Is orbiting a target isn't orbiting a target. It's not that we're locked onto a target and that the direction to the target is relevant. It's orbiting a target gives you a center. And that's all the orbit should care about. The direction isn't really relevant to an orbit. So let's start to map this out here. So we have the idea of a radius, which is how far from center. You know, what radius means. We have a velocity, which is the speed moving around the circle. So if we look at the circumference is like a racetrack. The speed that the vehicle is going on the racetrack is our velocity here. It is independent of the radius in any fashion. It is a constant in and of itself, or a value in and of itself. So it doesn't matter if I'm a mile away from the center or 10 paces away from the center. That's how fast it's rotating. For now, that will be a period thing. Like, that shall be absolute. We have the center, which is either an entity or a point. Which is actually ultimately a point. Could also be nothing. If it doesn't have an entity, then its radius doesn't really matter anymore. Yeah, I think when we're dealing with spiral and um yeah, a spiral needs a center. Whether that spiral stops at a point, it becomes an orbit, or it has an actual entity target. That's its center. So if it appears and it doesn't have an entity position, it says, okay, wherever I'm at right now is my center. This does get tricky. But we might be able to work with this. So now this is just naming convention. Is if the radius is changing over time, we're spiraling. If it is not, we are now entering an orbit. This is not really substantially different. The object will behave in pretty much the same fashion here. So we have the thing that is spinning, and we have a sort of tether attaching it to the center. So one thing you could imagine is like a weight on the end of a cord as it's spinning. You have the speed that it's actually moving outward from the object is that we're always applying a force outward on the object. It just can't go any further. And over time, it's rotating. Actually, no, we can look at it differently. It's mechanically. We have a force moving forward. The object is trying to move in a straight line. There is a corresponding force that says, I have a rope attached to you and I'm pulling on that rope if the rope is taut. So if the rope has reached its limit, that rope is going to be hauling back on you. But if the rope has not reached its limit, it's not going to. That rope is as long as the current radius. So the object's going to keep moving in a straight line along its line of velocity until it hits the end of that rope. The trick with this is that if the direction of travel is parallel to, essentially, if it overlaps the current vector of the rope, then we're not going to get the spiral motion. So we need to make sure that we're applying a vector that is that lines up with that. So we kind of have an L shape. So what we would initially do is look at it and say, like, okay, we Cough, cough, choke. So we take the initial vector coming out of the targeter, our starting direction. So we take that as the direction of the tether, which creates the one of the pieces of the L. And then we take the velocity as perpendicular to that. So that actually creates the L. It is possible that this vector is essentially 0. Because we have no pull on the cord. And that's fine. If we have no pull on the cord, then all we have is that velocity, that initial velocity. So if our distance from the center is greater than the radius, then we're going to apply the pull on the cord. I don't know exactly how much force we're going to apply, but for now we're going to apply the velocity again. We're going to haul on it as fast as it's moving. What that will do is, right now, that will create a 45-degree turn towards the center every time. Then we take that vector that resulted from this change and we apply it. Or we keep it. But we normalize it. We don't want it speeding up as a result of this. So we have this one. It has a particular speed. We apply this pull. If we apply a pull at all, as in the radius is being exceeded, then we're going to apply an additional force to it to try to pull it back in line. We'll create that adjusted vector, which will be actually faster because we're applying an additional force to it. We might adjust this, but for now, it's faster because we're applying two forces, the existing speed of the object as it's moving. Physics-wise, this is the constant outward force as it's rotating, but then we have we apply that, then we're going to normalize it down to a direction, and we're going to apply this original speed so that it maintains that. But now we have this new direction. The next time we come around, we're going to look at it and say, okay, after having moved, are we too far out? If we are, we're going to apply this new direction, we're going to apply the pull, and then we're going to store this. If at any point we're not too far out, let's say we're within the radius, we just continue moving in a straight line until we have to adjust it for the radius, until it hits the edge of the cord. The thing that makes it so it will orbit is the fact that we take that initial direction and make it that perpendicular. We make it perpendicular. We'll have to see how this plays out, though. We'll have to see how this plays out. We're going to call you the original move function for now. You are now move. Okay. So each time we move, we're going to look at our values. So this is when we're calculating it. There's still some wrinkle in this that we're going to have to work out. Say vector 2 is equal to vector 2, 0. One of the conventions that Godot engine suggests is that we would not do this. Instead, we would do this. This is implicit typing. Hey there, Ian. Welcome. What this says is last velocity is a vector because vector 2 is a vector 2 0 is also a vector 2. So we are setting the type just like doing this, but we're setting it to whatever this is. I don't like that. Because as it's called, that's implicit. We need to be very cognizant of what is coming back from this. If, say, this were a function or some other way of getting this value, or if we say, I would do 0.0, well, that would make it a float. But if I were to do 0 and not 0.0, that would make it an int, even if I wanted it to be a float. That's wiggly. I don't want my variable typing to be wiggly. Okay. We call it last velocity. We are going to use growth rate here. So growth rate is our actual velocity, but we need to get that perpendicular aspect to it. Spell that even remotely right. Okay, tether direction is equal to, as a vector 2, is equal to targeter dot direction or vector 2 right. If this is a true value, we should get this. Don't know if I like that. Okay, that's resulting in a bool. It's not. We're not working by C rules here, so that's somewhat good. I was just mentioning I don't like them to be wiggly. This prevent. Actually, that's an excellent example there. So, in the land of C, any number that is not 0 is true. And that actually works here. This is a vector 2. That is not an integer value. That is an object that contains 2 float values. But it is considered true. It has a operator like this that says if I am saying is an if I do a Boolean check on a vector 2, If any of its values are non-zero, it returns true. But that's a bool that it's returning. That is a true false that it's returning. If I were to do an implicit, if I were to just do colon equals and not declare it a vector 2, tether direction would turn into a boolean as a result of this check. That's not right. That's not what we want. We want it to be a vector 2. So we explicitly set it that way. That is why there was a syntax error on that line. The more you know. Now, we could make it so that the tether direction has a push to it. That is, that instead of a rope, we essentially have a spring that will push outward if we're too close and will pull inward if we're too far away. For the time being, we're not going to have that outward force. We're just going to have an inward force if it gets too far away. So no matter what, we have a direction here. That will give us our stored velocity, which should also always give us a vector to apply. And hello, Poland. Welcome back. Now we need to get a vector that is perpendicular to this one. We're coding circles today, Poland. We got the targeting working last time. We got it so that not only was the targeting not breaking, it wasn't reacquiring targets when it wasn't supposed to. That was largely a oops on my part. We also got it so that subsequent targeters can accept values from prior ones, which actually makes the movement order that much more important. Because if an intervening targeter doesn't accept a prior targeter's values, you can still get disjoint. That is, if I say home to target, and then I say move in a straight line in a random direction, and then home to target again, move in a straight line in a random direction doesn't care about an entity. It says, I've got my random direction. I don't care about those, so I won't accept it. Then when the next one comes along, it's going to say, do you want to take this entity from the prior one? It's going to pass nothing. It has no entity. So the next home to target has its own target, which could be opposite sides of the screen, which means those two homing behaviors are now going to potentially pull against each other, with the random direction being an intervening force. Unexpected result, and possibly detrimental, but it does promote the sequencing of the projectiles, which is what we want. I'm not parsing that sentence there, Ian. The meaning is not coming across. Last velocity is equal to tether direction, dot rotated, degrees to radians, 90 degrees times base growth rate times constant ha. And we're gonna abuse this a little bit just to get the line cut across here. Oh, okay. That would mess with your ability to type. Don't push yourself in that regard. If you have a sore throat, sometimes talking a lot can make it worse. Can I get away with this? Aw. How about this? Okay, so this is all contained in it. Let me do that now. Yeah. Yeah. Okay, we have discovered the Godot engine GDScript syntax for letting me do multiple lines like this. That's gonna help. Hello, cheese. Okay, so this is our last velocity now. And we know what the speed of that velocity always is. It's always base growth rate times constant square width. So now we need the idea of a distance to center. You know what? Let's store this off. This is actually not necessary, setting it to vector 2, 0, because declaring it as a vector 2 means it's vector 2, 0. That's the default state. I kind of like explicitly setting my variables when they go this way so that I know exactly what their value is at, when they initialize. I'm gonna make sure. Get this out of the way here. So if the template actually has a last velocity or a center position, then the subsequent ones are going to remember that as well. That Boolean is equal to false. We're going to use this because I don't want to... There's some weirdness that can result if we set the center multiple times. Okay, so we have our last velocity if we didn't have it. If not, center set. If targeter entity actually else. My cats were in an anime. There are actually a lot of cat-centered anime. There's one Chi-chan, which was pretty cute. There's one that I can't remember the name of, but you have a guy that adopts an arbitrary cat, and that becomes like the central conceit is him adapting to having a cat. Actually, there are a few like that where it's essentially the businessman living alone or the salaryman living alone adopts a cat. There are a couple of Hime anime, princess anime, and comparable spin-off ones. The effectively group "Oh Pretty Boys" style animes. That is, I recall there is one where a guy ends up indebted to kind of Japanese yokai style cats, so supernatural cats, and ends up being kind of a butler to them. A lot of cat anime. Cats are a popular Japanese pet. And hello, Laura. Hello. Okay, so if we have an entity, then the center position will constantly update to where that entity is. If we don't, we're only going to set the position once. And that center position is equal to entity to move dot position. And then center set is equal to true. Center set will always be true by the end of this, right? Oh well, we'll leave it that way. What this will mean is if the entity goes away, well, tech, that is a series of words. Yeah. Okay. So now we have a center. Yeah, but they also need to convey meaning in the context of the conversation that you're having. Otherwise, it's just sounds, potentially shouted into the ether. And that context is dependent on the participants involved. Okay, so we have our center. We have a two is equal to we want to get the reverse vector here because that's the relevant one if we need it. So this is entity to move, position. Minus center position. Oh, no, other way around. Yeah. So now our adjusted velocity is a vector 2 equal to last velocity. So then if to center dot length squared is greater than radius then the adjusted velocity equal to times plus to center normalized times base growth rate. A lot of what I'm saying in this scenario, in these streams, is stream of consciousness, aside when I see somebody has come in or asked a question. So if you do have questions, whether it's about something that is happening or, just you have a question or want to call something out, go right ahead. We have plenty of time to stop and chat. Short format, Frederick, is... Oh, and here, let me get you guys the link to the widescreen in case you want to use that. I forgot to get that set. Short form tends to attract more people because of its likelihood of appearing in a shorts feed. It is a more prevalent form of people observing things lately. You know, the proliferation of cell phones. Okay, so if we're further from the center than our radius, then we're going to add to adjusted velocity. Hey, Drew. Welcome. The second part of it, Frederick, is that because the shorts feed is more likely to get arbitrary traffic through it, it has more viewers, so it has a greater weight to people joining in. Whether it will have more viewers at any given moment is variable. Okay. So we take that and we're going to add constants square. We're going to apply this to the vector. We're doing pretty well, Drew. We are seeing if we can make spiraling motion, at the moment orbiting motion, more vector-based over time. So likely what we're going to end up with initially is something elliptical. What I'm hoping is that it will settle into a circular orbit if we leave it alone. But if the center position starts moving, we should get elliptical again. Let's find out. Velocity is equal to adjusted velocity dot normalized space growth rate, constants square. Remember that, and then we are going to say entity to move dot target movement. That's right, isn't it? Target movement. Move straight line. Move target movement. Yep. This equals adjusted. Okay. Well, isn't that weird? Whoa! Oh, we didn't include delta. All right, let's... Speed as a float is equal to base growth rate times constants dot square times delta. Delta is important. Something's weird there. Let's... Oh. Boop. Speed. 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 Well, I mean, that's a start. They are moving in a circle, so that's correct. We need the actual base max radius. Load is equal to base max radius times constant square width. Needs to be an actual square number. Okay. I mean, this is not actually what we want to have happen, but it needs to be smoother than this is the problem. Because it's only pulling when they hit that radius. What if... What if we always apply that inward force? Syntax error. That's what we... Okay, it never gets out is what happens. Always adjust the velocity by... Okay, no, we can't. So it's twisting it too much is the problem. That 45-degree turn makes it just ricochet around the circle. Right there. So it flies out in the straight line, straight down, and then you can see it's bouncing off at 2 squares. Anytime we're 2 squares out, it bounces off. our center position isn't being updated correctly, I think. We might just be getting our orbit wrong, but... So this isn't quite right. Because it needs to be pulled in. We are pulling it in. Stop trying to be useful, Godot engine. Same issue. Still the same issue. So this logic isn't quite right. Let's account for the change. That's better. We're still not getting a graceful curve, which I would like. You can see they're still bouncing off of the interior of the circle. So one thing we could do is make it proportional to the distance that it is from the edge of the radius. Float is equal to... We'll just do the square root here. It's not ideal. Actually, no, we can still do that. Okay, so we exceed it. So now what we want is a proportion to it, and say that, let's say if we're at double, then we hard pull it back in. So the proportion of the force that we want to use is going to be, we want it to be the full 45-degree pull if we're at double. So the less distance to center is compared to the radius, the less force we need. So if it's double, so it should be distance to center divided by radius. Radius times 2. So if it exceeds double, then we're going to get more than 1. If it's less than double, then we do less of that force. So this will soften it. It's still not quite, because when it comes out, it's a straight line. It doesn't get pulled much. All right, once again, if true, we're always going to apply this force. The straight line isn't quite what we want. We want it to kind of whip out in a circle until eventually we don't apply much of that force. All right, let's add the outward force here. Which means we want to be pushing it away as well. Oh, okay. We know what our distance to center is. We actually want a distance to the edge. equal to minus radius times radius. We're dealing with the squared value at this point. So now we have a non-squared value. Well, you still have a squared value. Okay, now we're going to use let's try that same formula here. Okay, we're getting a smoother curve here. But we're not getting it as cleanly at this point. Because we shouldn't be getting this straight down. This straight down should not happen. Because it's... Actually, no, it will happen. It will happen with greater force. We should be getting an outward curve as soon as it starts to get out. The further from the center, we should be getting a force in this direction. Because it's taking vector 2 right. It's going to the right, and then it's applying a downward force accordingly. But that's why. That's why. Because we're off-center. We're always using that off-center. All right, going to take a short break, and we'll think on this a little further when we get back. And now I'm back. All right, so part of our problem here is that we don't have the entirety of that outward force. We need to apply, and hello, Zell. We need to make sure that there is a force towards the center of the radius that we're actually obeying each time, or towards the edge. We've got the outward curve. It's this initial pattern in. I don't want it doing this out and wiggle. I want it to spiral out and gracefully enter the loop. As looking at it, so what happens is we have a straight down force, and it's off of the radius, so we're doing a big push here. Exactly. We have a. It starts out and it corrects itself to essentially a straight down push because its initial line of velocity is perfectly lined up with the direction that the radial correction is going to use. Now we could do that rotated degrees to radians. 1 degree. We make this 10 degrees. See, it corrects itself more smoothly when we're doing that there, but that's not really what we want to have happen. I don't want to rely on angular rotation for this, but that might need to be what's happening. We're going to force this. Keep that just in case. Radians. Proportion. Oh, it's going to fail because I didn't pay attention. Stop, save, run. It's back to the original pattern here. Yeah, I don't know that that's really what we want to have happen. Hello, Zane. Welcome, welcome. It needs to be like a spring. We need to make sure that that initial force gets applied to it. But the problem is, as soon as we're doing that, it turns into a straight line. We need to have that rotation into it. But how we do? Because to really make this work, we need inertia. Is the central tether, essentially the spring is pushing on it. But hello, Art, and welcome. We're working on circles in a game engine here. We're trying to create independent vectors to apply a rotation around an object such that it will spin out to the length of the chord, essentially, and try to stay there. But we're going to assume that the chord is more of a spring, that it flexes. But it will pull back in if it's longer than it should be, and it will push out if it's shorter than it should be. Yeah, so far geometry is winning. What if we were to still push? No. Because the target direction is reset every time. That's part of the trick, is when we're coming into each physics tick in the world, It's not like an object has inertia. It's that if none of the movers were to apply any velocity to it, the object would hold perfectly still. It would grind immediately to a halt. So we don't have the basic centripetal force thing that makes it so that there's always that outward direction, but that we're swinging around at the edge of the circle. It's the circle will just stop if we stop applying force to it. So we need to make sure that that circle is being adjusted accordingly. As such, I think we always need to look at it as if the force is coming out perpendicular to the center. I'm sorry, that the force is perpendicular to the line of the radius, and that we then apply that force differently based on whether we are closer to or otherwise here. Does not equal radius times radius here. So if it's off center, I believe that's the function that I'm looking for. Absolute value, yes. We are making sure that we don't care if the distance is negative here. We are looking at a vector inward. So we need to make sure that we can handle negative. So instead of referencing last velocity, we're going to constantly get the perpendicular vector here. Yeah. We don't care about last velocity anymore. Last velocity will let it move in a straight line, but we're immediately going to adjust it. Because we'll take that vector and then we're going to apply a push to it. So it will angle out. And then we're going to take that current position compared to the radius, and we're going to create a new perpendicular vector to it, and then we're going to push it out. Okay. So this is the first relevant thing. This is our direction to the center. Last velocity may still help us here. Because we still need the idea of what direction we're starting in. If to center, not to center, then to center is equal to vector 2. Right. Okay, if we don't have a direction for toCenter to work in, we're going to assert that it's a unit vector to the right. It is 1 to the right. Which is going to be wildly less. There is going to be a strong push right at the beginning. Because all radius is based around in units of squares, which is like 96. So a length of 1 is going to be a definite problem for it. Okay, so we've got that. So this gives us our vector to the center. So we have toCenter, we have the distance. So toCenter is our starting point. So then adjusted velocity is initially equal to we have the toCenter from center is equal to where we are in the center position. All right, Frederick, thanks for joining us. Rotated degrees to radians, rotated 90 degrees, normalized speed. Okay, this is our initial direction. So this is the perpendicular one. Then we're going to apply the outward force as needed. Plus, from center, normalized. Hey there, Delusion. It's moving along. It's moving along. We're working on circular motion right now, and it's a bit of a ride. It's a bit of a ride. Times speed proportion. It's getting 0 there. We know this whole logic that we've got by default isn't working. So let's clean this up. Okay, so here's our first entity coming out. It wants to rotate. So our speed is 0. Okay, that won't move. That's okay. Because our growth rate and our radius are things. It's that delta is a very small number right now, or 0. We don't have a target entity. Our center is not set. Our center is going to be set to 0. Up, center position, because that's where we're standing, is 0. So then from center is still going to be 0. Yep. So we're going to set it to right. So now from center has an x of 1, absolute to the right. And our distance to the edge is... So our radius is 192. Just a moment. Okay, that's about right. That's about right. We are very far from the edge. We're almost as far from the edge as we can get. Wait. Okay, this is part of our problem here. It's not equal to the radius squared. So again, distance to the edge is massive. So we have... which is essentially 1 off. So then our proportion is -1. So our adjusted velocity is still 0. Okay, well, we're getting a very fast internal orbit. We're not getting sufficient outer velocity, but we are getting rotational now. That's good. It's that outward push should be substantial comparatively, but instead we're constantly being pushed inside. Um, hey there, parakeet. Which reminds me. Well, I'll have to do that elsewhere, though. Okay. Gives us our 90 degrees, and then we want to push it harder. Um, Based on our distance from the center. So the second time we see this thing, it's going to start to the right. It's going to be heading down. So our first one should be a positive y by the time it gets here. Well, it's adjusted to nothing. Second time, tilting way up. From center shouldn't be negative. Have this reversed again. So the proportion is part of the problem here, I think. So the first proportion should be so this is where inside. So we want a positive force. So the radius is bigger than the distance to the edge. So right now we're applying negative. It's not quite right then. Let's reverse that. Aha! I had the proportion reversed. So this is centered wherever we were standing when it launches. All right, so now let's go into our catalog. It's going to target a random enemy. No, 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 no. Me load the mouse. Move orbit player. Orbit player says target random enemy. Let's look at that spiral again and make sure that we're getting... want that to be slightly faster so that there is an entity by the time it comes in here. So if you look at our targeter has no entity. I think there might be a problem with the way that the targeters are accepting their values. Log. Targeters. Okay, it won't accept. Set entity to random enemy. All right, it's not triggering that. But it should be. Yeah. Set entity is target random enemy entity. No prior movement yet, so... Something wrong in our catalog here, because target track random and... Oh. Target random enemy should still be getting that, though. We should still be calling that. Should still be calling that. Using move orbit player, which is target random enemy. Let's switch this to player for now. We're still not getting an entity. Hey there, Marcus. Okay, so our targeter entity is still not getting what it's supposed to. Entity to move. Delta. We're making a Vampire Survivors style game, a bullet heaven game. Real quickly here, we gotta check for a cat because I lost track of one. It's Ember across from the keyboard. Well, we got a double on the bed there. Mason and Sammy. Actually zoom in here for those watching in widescreen. It is. Learning to code is essentially learning math. Well, it's functional thinking. It's breaking things down into operations, things to do. Yo. Okay, they're zooming so fast to their target because of the proportion logic. And they're clumped up because there isn't any variation of rotation to that. But we're getting closer. I mean, they shouldn't zoom that much as far as getting into position. And I want them to still spread out as they move. But that's better. That's better. What if we rotate it? Marcus, that is one of my 5 cats. That is Ember. So if instead of proportion, we just do this. Okay. That's it can't be just times speed. We need whether it's positive or negative. Yeah, Super, that's the goal. Is to be akin to Vampire Survivors, but with a Noida style weapon construction. No vampires. That's just the style of game. This is all of the theming is based on character lore, and yeah, it's based on character lore. So we have some of the sprites in place, but not all of them. The blue things are Niano blobs. Hey there, Yassine, and demo. All right, that's not right, but you know. So we want this to be capped out. If absolute uh, portion. Okay, so if it's greater than 1 or less than -1, then we're going to convert it into 1 or -1. Still off target. This should be... Portion is -18, so that should come out as -1. Yes. Oh. I should use the value. It's probably a better way to do this math, but... Okay, now if we go into our catalog and we say target random enemy, okay, so next I want to get the initial target or direction to be relevant to how they come out. So float is equal to... starts out as 0. So we won't rotate it at all in this case. It's equal to targeter get direction. We have to make sure that we use get on this. It's at least once, the first time we reference direction in this function, in a movement function, we have to call get on it. If we don't, it never gets set. Okay, this will be in radians. So now we're going to do from center dot rotated Angle offset. We're going to remember their last velocity going forward. Because if they don't have a target, we don't want them to just spin in place like that. Well, that should still be working. We shouldn't be getting that little tight spin in place because we always have a center position, even when the thing is gone. And so we always have a center position. Whether it's, if we have an entity, we're remembering where the entity is as far as its center position. If we don't, we need to make sure it wasn't set. If it was set, as in we're updating the entity's position, the last time it was set when we lost entity, then that should be the center position going forward. It's showing this again. We lob a whole bunch of them at once. We're getting things like it hit an entity and then it just spins in place. But that shouldn't be the case, is the one that struck like that should know that that was the last position of the entity and then should fan out from there. It's, for one, that entity, the bullet should be gone. Slow down those blobs so that we yeah, every now and then, yeah, it's tightly orbiting that entity. It should not be able to do that. There should be an outward force on it. But that was a spiral in that happened. So there's something wrong with the math here. Um, as an entity, entity delta. Target entity 5. Just to be sure. All right, we're still getting the weird tight circle, so that's not the issue. We'll keep that target entity around just in case. So this will create an outward force. If we have a this is a from the center to the target position, I think. Position minus the origin. So yeah, this is from the center to the thing that is moving. If we don't have a vector from that, if it comes out 0, we're going to say it's to the right. Then we're rotating it based on the initial direction. This lets us preserve a fan-based pattern or a spread kind of thing. Any sort of logic that rotates the starting position to change the angle or the starting velocity. Let's make sure that this is We're still getting those weird little tight circles. Which we shouldn't be able to. It should be pushing it out constantly. And I think part of the problem there is this. So here's our initial direction. We're going to move this to a little later. We don't want to risk that targeter is changing its direction as we go. So we don't care about this, we care about angle offset. So then in move, not center set. Once we know the center, once we have done this for the first time, we're not going to adjust the offset. Nope, that's not right. We can't do it that way because the center set will come from the... We do need... We can just do this down in here. To right. I'll actually make that 0. not initial direction, then initial direction is equal to targeter.getDirection. Initial direction, then initial direction is equal to vector2.right. Try to get it. If we don't have it, then get to the right. We could store off the angle offset when we do this. Still not quite right. So if we remove the blobs entirely during this, then I suspect it's just going to spin in place. Yeah. There is no outward force being applied tangibly here. Because it should be the center point that it cares about. So as soon as this fires, we should have no target entity. Center is not set. Center position is 0. Setting the center position, right? Yeah. From center is to the right. This is saying we're 1 unit to the right. And we're going to rotate it by the offset, which is nothing. It's very slight. It's rotating it by 0 in the scale. Well, actually, isn't this returning radians? In radians, yeah. Then rotated should accept radians. Yeah. So degrees to radians is a little off each time. 061 each time. Let's radians to degrees. Oh, because that is angle right is not unrotated. That's fine then. We are getting approximately to the right here. That's fine. We're normalizing right, but okay, we definitely have an aberration in this logic. Because they're veering all over. It's I think the problem is that to center is not necessarily the one that should be rotated. I'm sorry, from center. So if we remove that rotation, felt like it should be right, but, it wasn't. Let's put the blobs back in just to be sure. Okay, so it was definitely the rotation that was a problem. If we don't calculate from center rotated, yeah, rotating this is going to be a problem. Plus angle offset. It's because this angle is fixed that I think we have the problem. Yeah, that angle offset still throws things off. The reason that we're doing this part at all, is that we want that fan pattern to be respected. So we were getting significant distortion in the way that they were flying out, because with the two center rotated like that, you could get a substantially different vector as far as the result when we rotate it. So one of the possibilities is that we rotate it initially when it's coming out, but we would limit the degrees of rotation. That's how we make it so that the tracking ones can come out like that. Do we have a starburst spread we can use? Make a new one. This. Do the same thing, but instead we're going to use 5360 here. And 360. And we'll go into the game and we're going to use 5360. Yeah. So these don't respect the spread, and that's what we want to accomplish here, is that they would come out in that pattern. But that creates a little bit of a conundrum for us, is how would we limit that turn radius? Because that's what we're actually accomplishing here, or that we would be accomplishing, is the difference, is knowing the difference when it's rotated. Because that's our turn radius limitation there, or at least that's how we're changing it. So we need to respect that initial direction somehow. Oh. Okay, okay. It's here that I think is relevant. Targeter, get direction here. Need to move delta. Not quite. because this is immediately overridden. It's immediately overridden as soon as we have the entity to move's position. It will almost instantaneously course correct and overlap again. Limiting the turn radius is, I still think, viable. So that we don't have that that immediate convergence. But if we do that, then there's a substantial limitation in what we can accomplish here. Direction. Doesn't matter. It's weird that rotating it that many degrees, it's like we're getting that initial rotation and saying that the direction should be tilted, but I feel like there's some more going on here. We already tried rotating adjusted velocity a little bit. See, if it's just homing parakeet, it's turn radius is something that is very important to it. Where if it reaches a point where to converge on the target, it would need to make a tighter turn, then better homing can do it. But worse homing is going to have trouble actually making that turn. And might result in that orbit. So I think that's kind of intended behavior. Tighter turn radius, better control means better homing, just straight up. So if you want it to be able to home precisely, give it like a 90-degree turn radius, you know? But otherwise, it's still possible that it could miss based on the movement speed of the target. Even with a really tight turn radius, if the target can move very fast and is outpacing it, then it'll never catch it. And you get those variations. You've got a lot of variables involved in that kind of homing. So, just just letting it be can result in neat behaviors. So I want them to come out in a fan, which means I need to limit its turn radius. I think I do. How do we limit this? Hey there, Lunar. Not yet. We are revisiting the orbital logic. We're looking at kind of the pattern. I thought again about the kind of thing you and Dr. Frederick were saying as far as changing our view of it. And right now, what we have is essentially a velocity attached perpendicular to a spring, is how we're kind of looking at it. If you're too close to the target, the spring pushes away. If you're too far, it pulls back. So we're creating that kind of rotation, but we're trying to figure out how to get the fanning behavior to come out initially. And I really think because this is effectively homing logic, that we have to have a maximum turn rate. Okay, so what if we constantly reassert? So we get initial direction. That's direction as a vector 2 is equal to that. And we get our angle offset. So we're constantly recalculating it. offset is 0. Okay, it still doesn't care if it's 0. That's okay. So then if it's not 0, then we get these big aberrations. Because the offset is not being calculated correctly as far as our, like, we can't offset that. So I think it is turn radius. I think it is turn radius. So we're going to have a last velocity still. Yeah. Still adjusted velocity. It's just adjusted velocity. If last velocity, if and put a true there so we can wrap that up. Okay. Radians, degrees. First, if we have a last velocity, then two as a float is equal to Radians to degrees, last velocity angle to the adjusted velocity. Okay. Angle is greater than 45. And adjusted velocity is equal to adjusted velocity rotated 5 minus angle 2. Right. Hey there, Maya. Welcome, welcome. This isn't right. This isn't right. Oh. Days to radians. We're doing okay. We're doing okay. We are working on orbital motion around a target. Better direction. Move delta. Still not quite. This only affects it the first time is the problem. And while it is a tangible force, it it's still allowing them all to come out in one direction. All right, thanks for swinging through, Maya. Okay, so this angle 2 isn't quite right. It adds another variable that is hard to determine if it's correct what we want to do. Because the actual angle of rotation limit is based on the radius around the circle, like point to point, what the radius of the circle and the speed of the projectile is going to be. Because each time we know what that rotation limit would be. So a bigger, wider circle would rotate slower, whereas a tighter circle would rotate faster. Or would be able to pivot faster to continue moving at the speed that it does. But no, the last velocity is not the adjusted one. The last velocity is what it would be if we didn't push it away. The last velocity is the circular. I'm sorry, is what it should be. So it's non-proportioned speed. So we don't have this plus in here. It's just the direction of from center rotated 90 degrees normalized. This is the original last direction. But it will still be distorted based on from center. Because if we keep this as like the maximum rotation that it can do is the distance between the last one and the current one, then it can always pivot hard. Because it can course correct almost immediately. We could calculate this. each time, if we have the speed, we can calculate the circumference of the circle. We can divide that circumference by the current speed and say that that is the number of segments that the circle is divided into. Divide 360 by that. And that gives us the maximum degree of rotation that it can do. Negative rotation is a problem, though. We need to be able to handle negative rotation. But that's fine. That's fine because we can just take it as the absolute value and say if that's too much. So what that would allow us to do is say that it can't turn any faster than it would turn along the circle. That can still completely negate the spread, though. So that won't help us, even if we do it that way. Because that angle of rotation might still be enough to negate that spread. Just trying to figure out why the initial from center. Well, the initial from center is being calculated based on where we currently are. So unless we move far enough out, it doesn't matter. So the from center being rotated should still be sufficient to get that. But it's how to get that later. So this last velocity stuff doesn't help. Get that out of there. And let's make an interim save real quick here. So we got move spiral. Yeah. Okay. So we can't mess with this. We have to have that 90-degree rotation. We can't rotate the whole adjusted velocity because that can result in the wrong kind of cornering. It can make it too tight or too wide to actually orbit correctly. Which is interesting, but not correct. We can't use turn radius here. You know, this might still work. Let's consider this. So if not center set, then angle offset is equal to targeter hit direction to T to move delta angle. Hello, Daniel. Hello. Cute, Marcus. Still working on the game, Daniel. Still working on the game. We're working on orbiting around a target using only vectors instead of calculations based on position on a clock face. So that we don't have forces that are too strong pushing it around. Might ultimately have to revisit that clock face concept in order to get things wrangled, but I think we're still good here. We're still ultimately doing that. Yeah. So right now the projectiles are trying to rotate around an enemy. And what we're trying to accomplish right now is that right now 5 of the mice are supposed to fly out in a starburst pattern, but the rotation isn't respecting that. So Marcus, integration with stream as far as like viewer interaction in some fashion, whether direct or indirect, is something that I ultimately want to have there. A defensive perk like that, like essentially a brief invulnerability, is something that might occur in the game. So this is largely irrelevant, is we can just use vector right here. Then we're going to do from center is equal to from center rotated angle offset. Have a good night, Marcus. Okay, we're still getting a pretty strong aberration here. We're going to change these over to orbit player. To actually target the player. We're going to remove the blobs. So that we can really see what's happening. We're also going to have move spiral. We're going to give its max radius out to 4 so we can really see it. So they're fanning technically correctly. They're coming out in different directions, but we are getting incorrect overlap when they're spawning. So you can see we are getting 5 of them created at a time. Up until it starts buffering, then you can't see anymore. But what that means is that the angles of rotation that we're getting as far as the offsets aren't being properly translated to this. So when we move spiral, I'm going to put a pass here so that we have a breakpoint. So we should get 5 of these in a... oh, okay, 1 minute. Now we're going to get 5 of these in a row when they happen. Okay, so angle offset. So 0. It's weird. Should be getting a lot more of those. That's why. Hello, Ember. Hello. Ember wants hugs. Oh, we got a triple. Mason on the tan blanket, Sammy on the pillow, and then Sherbet on the kind of comforter. So angle offset is 0. Okay, that's... Zero. It's not right. Targeter should be getting its direction. Oh, because we're targeting player. Not targeter direction, then... It's weird. Target player will never rotate its direction because it will always be toward the player. Right? Targeters, target player goes to player, so it's using a default targeter. Set direction. Which will return either a random direction or the direction to the entity's position, which should not be returning 0 every time. Should always be direction to the entity's position based on the entity to move. There we do else s, and we have a breakpoint here. Is never changing because it's always 0 at the time that we set it. So in targeter, in we rotate towards the entity, the direction is facing the entity. But if it's right on the entity, let's use set direction rotate towards entity on the catalog's target player. Action is equal to a callable, which is the targeter set direction rotate towards entity, not the result, the function itself, but we still need that because Godot engine is trying to be helpful and it's not. Okay, so target player will always try to rotate to face the entity, but its direction probably won't change it at all. The fact that 2 of them are coming out and it's slightly different is weird to me. Go back into the game and we're going to reset these to spread 3 and 90. Yeah, they're always coming out two at a time. Like visually two at a time, but it's the same number. But why are we getting two of them? We'll go into our move spiral and we're going to remove where we change angle offset. That's intrinsic. There's something weird going on there. Okay, and if it's noticeably slower, how are they coming out at different angles like that? Like, that's what we want them to do. We want them to come out in a spread like that. But they're not. They're coming out two at a time. This is so close to what we want, but it's missing a key element. So we're always not getting a direction. That's part of our problem there. So again, we're going to have we're going to target a random enemy. It's going to be track random enemy. It will always have the facing based on a position to that entity rotated accordingly. Okay, now we're going to go into the game and we're going to add blobs, but they're only going to spawn once every 5 seconds so that we get some very clear behavior. So when they have a blob target here, they all group together. It's only when it's 0-0 that we get the oddity. We apply template. Don't need any of that. Same way we don't need a last velocity. if we limit the turn radius, it can still override the initial direction. But let's calculate that out. Float is equal to times I. We'll just put that there. Circumference divided by that. So this should truncate it. So divided by iterations as a float. So this is our initial turn. Okay, so this is our proposed direction. Here's the adjusted one, which is proposed direction. Proposed direction times speed, and then from center normalized times speed times the proportion. So from center, not rotated. Okay. If float is equal to adjusted velocity if the absolute value of turn, then okay. Let's the vector 2, new proposed is equal to proposed rotated max turn times absolute value to is in degrees to radians. We'll clean this up in a little bit if this works. So new proposed dot normalized times adjusted length Hey there, Sapphire. All right, let's get them back to a faster speed here. Can move 5 squares. Max radius of 4 is still good. Okay. This is limiting the rotational, like the adjustment to the rotation to not turn any faster than it could initially. So no matter what, it can't turn any faster than it would around the edge of the circle. So if we have a great deal of speed on it, it can very quickly move out to its maximum radius. We are going to need to make sure that we're adjusting that outward force, though, because that max turn radius is messing with it. Let's turn off the blobs. And we're going to go into our catalog for move orbit, and it's going to target the player. Okay, it's acting as a spiral because the max turn base max radius in that calculation, don't I? That's as far as it should be. Base max radius. Circumference is based on the radius. We need to make sure that the radius is being limited by delta, or the turn rate. Oh, we're still spiraling out. It's because we can't turn inward fast enough. points. Make sure we get that in there. Still spiraling out. Why isn't this working, though? Well, we know the radians to degrees isn't perfect. Next turn is in degrees. Wait a minute. Those numbers don't seem right. Speed is 0. How are we getting 11,000 iterations? The radius is 192. Circumference is plausible there. Yeah. Base growth rate is 10. It's 960. Oh. So that's fundamentally different. Okay. Equal to targeter, get direction, entity to move, delta. Since we're targeting player, we're going to keep this here for now. We're gonna add still 2 of them coming out. They're also coming out in slightly different directions there. So if we go into our catalog and we lower their speed, one square a second out at 2 is its max radius. I do want to make it so that if it's going out to the radius, it can be faster. If it's going in, the outward force should push it harder. And we don't want to make any assumptions about the direction of the turn. We should make it a little faster. Can't see it when it's so slow. Not sure what the question is there, Cielo. Said, can you? Sure, is it a translate issue or something like that? There is no fireplace here. Huh. We could accelerate it when it's not at radius. I mean, we're still not getting the spread, which is what I want to accomplish. So we're going to have to think on this a little bit more. Gonna have to think on this a little bit more. So let's wrap it up here for tonight. we've got the spiral motion out to vectors. The thing that we don't have is the ability to set the initial positioning of it so that at least when they are emitted, they come out in like a cone or a starburst or similar. That initial direction. I think that's what we're going to have to deal with here to make it function. Actually, well, one more quick thought here. So this is our default. And it's always the same if the targeter has no direction. So targeting the player intrinsically doesn't have a direction. We need to work on that. Direction default. If not direction. Okay, so we have a direction, which means we have a direction we can rotate. So coming out like that, but if now we go into move spiral, or hit direction. Delta. It's from center 0 when that happens. Oh. Because with target player, we're still coming out as 0. That back. Set values. Our direction is a vector 2. That still won't change it. So the problem is if we get no direction at all, if we get a 0, we need to be able to handle that properly. Direction, prior direction, vector 2, right, and direction is equal to prior direction. Okay, from center is now equal to right in that scenario. So then aha! Yeah! I think it's working. Okay, now we are going to go into our catalog, and in our orbit player, we're going to do target random enemy. And we are going to go into the game, and we're going to add enemies. Okay, the default is still tracking the entity, I think. So it's still converging in that scenario. And the turn radius isn't enough to stop it. Load movement. Orbit player has a growth rate of 5. So if we set it to 1, it will be substantially slower. They're still immediately locking down because it gets an initial direction, and that direction is still straight at the entity. It's not being altered. As soon as we have an actual direction, then it locks on. It says that's the direction. And rotating the angle 2 is just going to throw things off. All right. So we need to need to think on this more. And I didn't put myself off center, so I've been talking over top of the code. You haven't been able to see it. But you know. Okay, so we've got the orbital motion working in general. The wrinkle that's missing is starting positioning, starting direction that it comes out. That is being thrown off by the current logic. Because if the target is far away, then our target positioning, our course correction, immediately twists it to come out the way it wants. We don't get a slower arc in. What we might have to do is reduce the max angle change if you're too far away, so that it takes time to like pivot to get to the target, to like rotate to face the target if it needs to. Okay, we'll think on this further. I don't want to get caught in a in a loop of but what if. I've got a thought, but we'll save it. We'll save it. Well, I hope everybody had fun watching today. Said we did make some progress. Hopefully more in the future. We will be back tomorrow, continuing along. Don't think there's going to be any interference with that. But I will adjust it accordingly if necessary. In the meantime, if you like what you saw and would like to see more, remember to like, follow, subscribe, that sort of thing. It helps the channel grow and will help you find things you like in the future. With all that said, I hope the rest of your day is good, and good night, everyone.